Hello students, today we're going to talk about measuring and classifying angles. Don't forget to take notes as you go and complete the survey that follows this video. So recall in a couple of videos ago we talked about angles. Angles are two rays that share a common endpoint provided the two rays do not lie on the same line and that the common endpoint is known as the vertex. And we looked at a picture of what an angle looked like, and then in class we discussed how to name it. So this is angle DEF, or we can call it angle FED. Again, we can see that the vertex is in the middle there when we're naming it. We can also call it angle E as long as we don't have another line coming out of it. And also, if there is a number in front of there, we can call it by that number. So this would be angle 1. So that's just a reminder of what an angle is. So today we're going to go about continuing talking about them and how we measure them, as well as how we classify them. So we have an instrument that is just like a ruler that measures an angle. However, it's called a protractor, and this will measure an angle. So you can either read it from left to right or right to left. Make sure that you use a little bit of common sense when you're doing it. When we're reading, say, find the angle GHL, we're actually going to be looking at the smaller numbers we're going to follow from the outside value here. So you can see that the measure of the angle GHL is 90 degrees. We could also go the other direction. Say we're looking in this direction here. When we look at this measure of the angle, it's clearly not going to be 125 degrees, but instead it's going to be more like down here at the 55-degree mark there. And there's two ways that I can ask you to find the measure. I can say, what is the measure of angle GHK? Or I can ask you to find the measure using the letter M of angle GHK. So with line segments, we said we want to know what is AB. We don't need to use the letter M or anything like that, but without having anything up top here, we can say that we're looking for distance when we're just saying AB. But however here, we're going to do measure of angle, and then we're going to list our angle right afterwards. There are 4 ways that we can classify our angles. This may or may not be familiar to some of you. If the angle is between 0 and 90 degrees, which means it's not equal to 0 and it is not equal to 90, then it is an acute angle. If it is exactly 90 degrees, it's a right angle. And we typically use this red box here. It's red here, it might not always be red. We use this box here to indicate that it's perpendicular or that there's a right angle there. If it is between 90 and 180 degrees, so again, not equal to 90 or not equal to 180, then it is an obtuse angle. But if it's equal to 180 degrees, then it's known as a straight angle. And you can see there are 2 rays that make it up, or it looks like a straight line. So, just like with line segments, we can add angles together. The whole thing is that they have to be adjacent, which means they're sharing their one side like this one here. So if we were to add the angle, the top angle, the bottom angle, we're allowed to do that. We can get a total for the measure of angle RST. So that's this angle addition postulate. Remember, postulate means we don't have to prove anything about it. But as long as this is inside, this point here has to be inside of angle RST, then the measure of RST is equal to the sum of the measures of RSP and PST. Just like with congruent lengths, we can also look at congruent angles. Congruent angles are 2 angles where they have the exact same measure. So remember before, when we talk about measuring them using degrees, we use an equal sign. However, if we're comparing the 2 together, we're not looking at theirs, but because they have equal measures, that means the angles themselves are congruent. Just like we also had a segment bisector, we have ourselves angle bisectors. So an angle bisector is a ray that divides an angle into 2 angles that are congruent. So this guy here, this is our angle bisector. In order to indicate that we have ourselves 2 congruent angles, we use those arches here to indicate so. So when we have one arch, that's showing that we have ourselves 2 congruent angles. If you have any questions, please make sure you write them down or fill them out in the survey. Please make sure you complete the survey that follows this video. See you tomorrow.